Okay, so for this investigation, we are actually going to use something called diffraction grating. And what it is it's a very special, expensive piece of what looks to be paper, but it has thousands and thousands of tiny little prisms in it, like 1,300 of them per square inch. And as you can already see in the fluorescent lights behind me, the diffraction grating actually separates the white light, or any light coming into it, into a prism so that we're able to study the spectra. So I'm going to turn the lights off, and we are going to look at flashlight. And then we're also going to look at some specific elements in gas tubes and look at what their spectra look like through the diffraction grating. Okay, so for our first test, I have a flashlight. So I'm going to turn the flashlight on and shine it at you. And you can see with the diffraction grating that you get a spectrum right down the middle. Okay? So now let's turn the camera so that you are able to see the gas tube. All right, and in each one of these tubes, they only contain certain elements. And I do want to do these in a specific order for you. All right, so this first one is hydrogen. And as you will learn, this is what most stars are going to be burning. Okay, so that's what it looks like prior to diffraction grating. And here's what it looks like. Let me try to move the camera up a bit. This is what it looks like with diffraction grating. So you can see that we do not get the same type of diffraction that we do with just typical light. Okay, with typical light, we got that full spectrum. We got all the colors of the rainbow. Up next is helium. So totally different color. A lot of times parking lots will have helium lights in them. And I'm trying to get there. So there's the spectrum. You can see that it's very heavy in the yellow and orange. So heavy, in fact, that it just about excludes anything else. Here is neon, and this is actually how neon lights are made. Woo-wee, check that out. Let's see if we can get, oh, look at that spectrum. Okay, so again, we have almost everything in the red and in the orange, but we're not seeing much of anything else in terms of color. And last but not least, here is xenon. So some of you may be familiar with the xenon car lights. So they're kind of a blue tint. Let's see if we can get there's the spectrum. Okay, so we've got a lot in the blue, in the green. There's just a smidge of red there, not a whole lot. So the same way that we can isolate different gases in the elements and put them into tubes and then light them essentially on fire, It's the exact same thing that stars do. So based on the color that a star is burning or glowing, you are going to see that we can study its spectra. And from studying its spectra, we can learn all sorts of things about its color, how big it is, how hot it is, and about what stage of its life cycle it is in. So please join me on the next video.